Welcome to this tutorial on post-processing in Flexcom. My name is Angus Connolly and I'm the product manager for our Flexcom software. So now I'm going to show you how to run some post-processing in Flexcom to extract results from a previously run simulation. In Flexcom there are two main types of post-processing options. The first is called database post-processing, and this is largely used to create plots and graphs and visual output. The second is called summary post-processing, which is a much more concise text-based output. So we'll see both during this tutorial. I'm going to start with the model I used in the previous tutorial video, which is just a dynamic simulation of a steep S riser. So in the dynamic keyword file itself, I'm going to start adding a database post-processing section. So we'll just use the keyword editor for now. Because it was a regular wave simulation, we'd like to look at some statistics of outputs. So let me look at some statistics of forces. I will use an envelope option, which gives me the maximum and minimum values in the simulation. It's asking me for a start time here, so because I ran for 5 periods in terms of the simulation, I might just take to the last period for statistical purposes, because the response should have reached steady state by that time. I don't apply a scale factor. I can be throwing some units. I'm looking at effective tension here. I'll explain in a moment what those degrees of freedom are. So I'll also look at effective tension and resultant bending moment, let's say. So I'm just going to copy that line. So this should be in kilonewtons for tension. And the next one is exactly the same keyword format. I'm looking for an envelope plot. But this time I'm going to look for bending moment rather than tension. If I just switch briefly up to the table editor, which I don't normally use because I'm very familiar with the keyword editor, but you may prefer to use the table editor, you can see that the inputs I have here below have just been replicated up on top. So it's an envelope plot, which means it'll give me the maximum and minimum of effective tension and bending moment over the full riser. I didn't even bother selecting the riser set, but you can do that there as well. Just be careful then when you want to run the post-processing that you don't accidentally push the run button, because that will rerun the entire simulation. We don't want to do that. We just simply want to run the post-processing only, which will extract the data for us from the simulation database. So let's just wait while that generates. It should create some two plots for me, which we see on screen here now. I'm just going to double click to open. I'll just close the model view now to make the plots a little bit bigger. So this is a plot of effective tension envelope along the element set riser. I'll do a separate tutorial on the plotting module itself, but you can just see that it plots the maximum effective tension as a function of length along the riser over the course of the simulation. And because we have max and min, we get two data series on the graph. If I just switch on to the next plot, this gives me a plot of bending moment, the maximum bending moment, again an envelope plot, so I've got a max and a min value, and you can see the range in between. If I wanted to, I could maybe just quickly identify where the maximum bending moment is using my tooltip option here. So I'll turn on this tooltip option and I look at, so the point on the riser which has got the maximum bending moment is element number 44 at the end of it. So let's have a quick look at what that might look like in a time trace. So I'll throw in a new keyword here called time trace. This would create a time history rather than an envelope. Again, I'm looking for a force. Element was 44, the end is 3, so I'm looking for rate for bending moment, and the units will be kilonewton meters as before. So let me just quickly rerun the post-processing, and now I'll have 3 plots out of the 2 envelope plots of tension and moment, and I should also have a time history plot of moments at one single point on the riser. So this is the time history plot, and what I've seen here is that because I've just ran for a couple of periods, it hasn't fully reached steady state, so I might need to run the simulation for a little bit longer. So if I wanted to do that, I could go back into my simulation and, change this from say 5 periods up to 10 periods or whatever. So you can see there that the benefit of database post-processing is that it's very visual, very plot based, so you can actually see what's going on and you can interrogate results quite easily. If I wanted to see where that point is in the model, I'll just turn this back on, the model view back on, and I would search for element 44 using the search facility down here. So it'd be element 44, find the element, and we can see that the maximum bending moment in the riser occurs at the peak of this point section. It's quite a crude model. I haven't used quite a lot of elements there just for simplicity and quick run times. So that is database post-processing. So again, it's very visual. So let's switch back to our input file, and this time we can add some summary post-processing. So again, I normally use the keyword editor, but maybe you may prefer to use the table editor because the program is new to you. If you wish to use the table editor, you just simply right click up here to add new menus, new tables. So in this case we need to add a brand new section. So I'll add a section called summary post-processing as opposed to database. Once I open the summary post-processing section, I can add a new feature. So if I want to replicate what I just saw on the database side, I'll ask for some force envelopes. The element set name will be riser. I'll look for effective tension, and the units for effective tension will be kilonewtons. And if I add another output here, I'll have let's say resultant bending with units of kilonewton meters. There are options to plot envelopes as well from summary post-processing, so you can just set the plot option to yes if you want, but the vast majority of users don't do that, and I'll show you in a moment why they don't really need to. So again, I just need to save the file and just run the post-processing only. I don't want to run the full simulation, I just want to run the post-processing only. So you can run it from the shortcut up here, or you can simply right click on the analysis itself. But again, don't fall into the trap of pushing the run button. You need to actually push the run post-processing button, otherwise we'd rerun the whole simulation. So I'm just rerunning the post-processing, which will recreate the 3 plots which I've already showed you, but it will also create another output file, a text-based file called a sum file, an SUM file, which is quite useful. So just double click on the sum file, and I'll just hide the model view just for ease of viewing. So what this has presented to me is the maximum and minimum values over the course of the simulation in terms of effective tension and bending moment. I actually forgot to give these names here, so that's why they don't actually have any names in the output. I'll just rectify that quickly so you can see. It's quite important to give these names to make them meaningful later on. So I've only looking for 2 parameters here, tension and moment, but you may wish to look for different types of parameters in different regions of the model, and you can end up with quite a bulky summary file. So it's good to give them names which make sense. So I've rerun the post-processing. You can see so the maximum and minimum effective tension, and the same for the bending moment. In this case it's a regular wave simulation, so we don't really have any standard deviations, but if we did run a random C analysis then we would have. So you can see that the tension values there, let's say that if we look at it, the minimum tension is about 3 kilonewtons up to about 75 kilonewtons. So if we go back into the plot here of effective tension, we'll see that the minimum right down at the bottom here is, it's quite close to 0. It looks about sort of 3. There's even a crosshair there if I want to check it out what the minimum value is, and yeah, it's about 3.4, and the maximum value, which is just hidden behind the legend there. I can push the legend to one side, and the max value is indeed again, sorry, I need to move the legend one more time, please bear with me. Let's push it down to the bottom corner, and it's about 75 whatever kilonewtons. So if I go back to here, that's pretty much what I was talking about. So you can see the contrast between the database output, which is very plot based, and the summary output, which is purely text based. So realistically, the summary output for one single analysis is quite useful, but it's much more useful when you start to look at many different combinations of inputs, like different wave periods, different wave amplitudes, different wave directions. You can create a text-based output, a summary output for each individual analysis, and then you can collate those using a summary collation feature, which I'll show you later on in a subsequent tutorial. So just to briefly recap on what we've covered in this tutorial, we've looked at the 2 main types, which are database post-processing and summary post-processing. Database post-processing is very good for interrogating a single analysis because you can create plots either in terms of envelopes or statistical extremes, or actual time histories where you can really go in there and look at the movement or the response at one particular location in the model. And then the other option, which is summary post-processing, is very, very concise, and you just get a handful of numbers which tell you what the max and min values are over the course of a simulation, be they measured extreme or statistical extremes or so on. So that concludes the tutorial on post-processing in Flexcom. Now I would like to go on and do some further tutorials which will show you the model view. The model view is a very, very useful tool, so I'd like to show you that one in more detail and show you all of the options that are associated with the model view, and also I'd like to show you this plotting module in more detail. So I'll do 2 separate tutorials on each of those as well. But for now, this concludes the tutorial on post-processing, and hopefully you can join me for the next tutorial video.